give you some general, just one slide introduction to design patterns. What are really design patterns? What are really patterns? So patterns are actually a way, like a template, for you to solve a particular problem. So maybe a problem, problems of a similar nature just reoccur over and over again. You just want to have a good solution to actually solve that particular problem, right? So now we'd say design patterns here are solutions to problems that arise when the software is being developed within a particular context. So the key word here is not just solutions. So it's important to know that it's for a particular context. Okay, so that means one pattern might be good in one particular scenario, but it may not be good for another scenario. Okay, so it's extremely important that you see the caveat here. So a pattern is only suitable for a particular problem. So now, as I introduce more design patterns in the course, you always have to get yourself not lost. You have to always ask yourself, what's really this pattern supposed to do? What kind of problem is it trying to solve? Okay, before you understand the solution. So in some way, the problems are actually more important to be understood by the solutions themselves, right? So let's say in the exam or the test, I might describe a particular problem to you, and then I say, I'll give you a list of, like a catalog of patterns, and I ask you which one might be more suitable to be used for this particular problem. Let's say if you choose pattern A, justify why, and then after you justify why, and do it. Okay? This is how I will test you about it, I can already tell you. I wouldn't actually just tell you to define what a pattern is. What that particular pattern is supposed to do, just apply that to the problem. Okay, so it's very important to know what's really the precondition for a particular pattern, because if you try to apply a pattern to the wrong context, that's worse than not applying the pattern in the first place. Okay, that's a very important concept to know. As the first slide. So now, let's talk about the first pattern. It's called the iterator pattern, and you might have seen more or less how that works in iPhone already. And let's consider this. Hopefully this might seem familiar to you, because this actually comes from our exercise 2 of lab 2, right? About how we define the shop and the car. I simplified that a little bit, okay? Let's simply, let me just go over that review to see, and then I'll ask you what the problems are here. So here we say shop, we have a shop class and we have a cart class. And apparently shop is actually a client of the cart, because the shop has a cart of type cart. And here we say to actually check out, we simply just want to return the total price that's calculated on the basis of how many orders or what orders you have in the current cart. So here we simply just say, because we have cart and we actually have orders here, which is defined to be an array of orders here. So we simply run a loop, and then this is actually a typical way of how you iterate through the array in iPhone. You just go from lower until the upper, and then you just keep incrementing the loop counter here. And then in each iteration, you're going to accumulate your results, which is of type integer, like the price, assuming that the price is integer. And then accumulate the result by calculating the price multiplied by the quantity. Okay? That's basically what shop and cart are supposed to do. Now, what problems do we have here? I'll give you a moment to think about. This can well be a test question, right? First question would be, what problems can you see? Oh, result here? Because you can see that checkout is actually a query to return something. The result is actually a keyword reserved in iPhone. Oh, good question. So because integer is actually an expanded type, so it always has the default value 0. So you don't have to explicitly assign that to be 0. Although I could have, but that's not an issue here. Yes.
The information is not hidden. The cart, the orders.
It's not hidden?
Yeah, it's not.
And what's wrong with that?
It can be dangerous when the client can access the array.
Okay, it's dangerous, and dangerous is one part, because the client might actually mess around with the array. That's one thing. Okay, what else? Yes.
If the upper is lower than the lower, then we could go into the infinite loop.
If the upper is,
Lower than lower.
that's actually not possible for the alpha array because it's some invariance, making sure. Yeah, but that's what we try. Yeah. Yes.
We have to do the required.
For which feature? For the checkout?
I know it was before do,
You mean for the checkout you have a precondition? What kind of precondition do you have?
before do, we need to do the requirement.
No, we simply just want to calculate total price for the car. Yes.
Could the orders change when the market, like the movie short?
Could the arrays change?
The orders array, like the orders in the array.
Oh, let's assume there's no concurrent access to the order. Let's assume that. Okay, wanna try? You know, this, Chris, yes?
It's dependent on the type of array that you're using.
How?
For example, you're calling dot price, dot quantity.
Price and quantity are actually specific to the order class. So maybe I think what you meant was we are trying to call lower, upper, and also the, yeah, lower, upper.
Programming to interface rather than, or sorry, you should be programming to an interface rather than.
Very good, very good. Yes?
I think the part is dependent on orders. I think they need to be separated.
It should be,
They need to be separated.
well, they are already separated in different classes. Somehow what you meant to say is you want to be hiding it, right? Okay, so now the correct answer for this problem is, because you can see that from the client's point of view, I depend highly on how the supplier implements the orders using an array. Because you can see that, because I'm depending on the fact that currently it is the supplier is implementing the orders using an array. So that's why in my client's code, I have to actually use features that are specific to the array class. So here you can see lower, you can see upper, and you can see, yeah, exactly, just lower and upper. So those are just typical usages from the array class. So now, information hiding tells you that if somehow the secrets of the supplier changes, it should not affect the clients, right? So now, because you can see that here feature is not exported to none, so that means any clients can access the orders. But now what if I change from array into a linked list from the supplier side? Would this code compile? It wouldn't, because lower and upper are actually simply a feature that's specific to array. They are not defined in the linked list. So this would suddenly become uncompilable. So me as a client will be very upset. You know, my code used to work, but now since you change your code or change your interface, it affect me. So that's not good. So what I said in the tutorial was, what we should do, step one, apply information hiding. So we should export this feature to none, as I said in the very beginning of the lecture, right? If we export this to none, this code, again, wouldn't be able to compilable anyway, because now the client is not allowed to use the orders directly, right? Because the order is not exported to this client here. So certainly you cannot say card.orders. This, so let me, I don't think this part is necessary anymore. So to be more precise. So now, let's say if I add a none here, if I say feature is exported to none, then on the client side, if I say card.orders, which means I'm trying to access his orders through this card. This will not be allowed anymore. Okay? That's actually good, because that will actually prevent the clients from depending on the supplier's secrets. But this is only step one. But step two, somehow the supplier has to provide some information to the clients, because the client wants to do the checkout at some point, right?
I was just going to say maybe the supplier should create attributes.
Attributes or queries or something, right? So there's some information that the supplier should reveal, but that shouldn't be like a secret, like an array or linked list. Okay? The solution I gave to you in the video is one way of solving this, which is, let's say, specific to this checkout feature, I can, for example, define a feature in supplier called get, let's say, also checkout. So the checkout feature in the supplier will actually use the secrets of the supply itself, which is okay. Because actually I'm moving the burden from the clients into the supplier. So here for the code, it would just be as easy as if I simply say result, let's say cart dot check out. Just one line implementation. Okay, somehow the way to check out from a particular cart is hidden completely from the clients. Okay, that's one solution. There's another solution to that, which is more general. So somehow we want to let, so you can see apparently array and linked list or even tree structure for the representation of the orders, they are completely different. However, there should be a way, maybe a more generic way for the clients to actually walk through the structure in a linear fashion. Okay, let me illustrate what I meant. Let's say, again, so always we distinguish between clients and supplier. Okay, let's say now the orders is actually hidden from the clients. Implementation one. So let's say we're trying to use an array to represent the orders. Let's say here are the order. Let's make it simple, just 2 orders. Let's say. 3 maybe. Okay, so now let's say we have order here. Let's say we have 3 orders here. So that's first element, order 1. Second element in the array, order 2. Third element, order 3. Okay, that's the first possible implementation for the orders, right? Okay, we have an array, so this is orders. Okay, so this points to one order object here. The second one points to another order object. This one points to another one. Okay? What about implementation 2? Let's say you're trying to use a linked list. The way, so roughly, so orders will now refer to a linked list object, right? So basically, of course, there's a simplified view of the linked list. Okay? So this is a linked list, which is internally very different from an array. So in this case, they also refer to, okay, let me try to draw in a better way. So from the other way, they also refer to the same order objects, right? Although we have different representations of how the orders objects are organized, but they're really referring to the same order objects, right? So here are the orders. So the first one is array implementation. The second one is the linked list implementation. Let's have a third one to illustrate the point even further. So let's say we have a third one. So these are all secrets for the supplier. So clients does not care. They don't care about this detail. Okay, let's say we have implementation 3. Let's say we have a binary tree for storing the orders. So we have the root here, there's a child here, there's another child here, there's a tree, right? So somehow, this points to the first order, and this points to the second one, this points to the third one. I know it's a little bit messy, but you get the idea, it's not difficult, right? So now, although we have different representations for the internal structures for the orders, but the orders objects that are referred to by these structures are exactly the same. So now when I said they should be able to be accessed from the client's point of view in a linear fashion, in the sense that the client should be able to focus on just this column here. They should just be saying, just give me the first order, give me the second one, give me the third one. I just want to run the loop, no matter how you actually implement the internal structure. So So for example, in this case, if I simply do some in-order traversal of the tree, I can actually get first one, second one, and third one. For the array, if I simply just go from upper to lower, I can get first one, second one, and third one. For the linked list, start the cursor and go until the end. Just get each item that the cursor is pointing to in the loop, right? So just different ways of representing the internal structure, but shouldn't affect the way that it should be accessed by the clients. Okay? So now, from the client's point of view, as far as they're concerned, they want to have just some kind of loop. From until here. For example, they have the checkout feature here. Okay? So now checkout feature. But somehow, they want to have a way to actually iterate through the list of orders that's actually maintained by the supplier. Okay, without worrying about how they are actually internally represented, either by array, linked list, or tree. So far so good? Okay, I haven't talked about how to do that yet. Okay, I just want to give you some intuition. Now, okay, we know the problems already. So now, that's the architecture of the iterated pattern. So please refer to the relevant page on your handout. Okay, yeah. And by the way, this is something you should really start practicing drawing. So I would expect, I spent only about 1 or 2 hours on this to actually get this quality. So I would say, once you spend a few hours on that, you can draw certainly better than I do. I have no doubt about that. All right. No?
Oh, I agree.
Good. You guys are more intelligent than I am.
Oh, of
No?
course.
Okay, so now let's have a look at the iterated pattern. Okay, so you have your handouts, but I'm going to point to the relevant places. Okay, don't worry about the client just yet. Worry about the supplier first. So basically, the overall picture is in IFO, you actually have a class which is deferred. That's why you see the star. Right? That's deferred class. That's called iterable. Okay? In this case, we want, because in the supplier, we are really talking about the card class. And the client is trying to use the card. So we want to somehow make the card iterable. Okay? So here you can see that the descending classes, the child classes, oh, by the way, so you can see the dashed line boxes there, they represent clusters. So this is actually a good way to organize your relevant classes into a single cluster. Okay, so now I'm trying to say all the classes in this iterable collection here, so you can see, I'm just giving you one example to illustrate the architecture. So in this case, array, linked list, and also array list. So all these three classes, they are iterable. They all inherit from iterable. Okay, that means if somehow the client actually code from the interface but not the implementation, right? So if somehow the clients actually say, should be something that's iterable. This is really the key. So this is why I said the code to interface but not to implementation is important. In this case, iterable actually can be inherited by many possible different collections, including card, can be array, can be linked list, can be array list, can be many others. Okay? So but as far as the client is concerned, they only have to rely on the interface for the iterable. Okay, so what do we have for the iterable? So there's one single feature in the iterable, which is called the new cursor. So that's why I said we want to access the business objects here in a linear fashion. So we want to somehow return a cursor to actually let us to walk through these lists linearly, in a linear fashion, like a one by one for the clients. So that's a completely different view as opposed to the supplier. So the supplier is actually much more complicated. They might have implemented some very clever logic to see how to store the objects efficiently. But as far as the client is concerned, they just want to walk through the objects. They don't care how you store them. Okay? That's why the iterable is a very valuable class to inherit from if you want to provide just an access to for your clients. Okay, so now you can see that from the iterable, so iterable is actually deferred class. If you actually inherit from there, that means you have to define the feature called new cursor. And the new cursor actually is of type iteration cursor. That's why you see a client-supplier relationship here. And in the deferred class, okay, you can see that this top level here is all deferred. That means that's where you have to inherit your own classes from. Okay, so here you can see that it returns a new cursor. A new cursor is of type iteration cursor. And you can see that it has a generic parameter, which means depending on what object, what types of objects you store in your collection. So in this case, for the card, because we're trying to store order, so it will be iterable order, right? Okay, which is instantiates the G by order. Okay, so let's go on. So now we can see the features. Okay, let's say, and here once you actually have a new cursor, you have to define all these features to actually let the clients iterate through the collection. So there are, let me see, there are actually 3 features that are necessary. You can see after item and forth, and they should look familiar to you because that's how you actually do the linked list traversal, right? So now we are providing a uniform way of accessing array list, and linked list because they are all iterable. And we can simply walk through an array by using after item and forth. Okay? So now, so here you can see that the descending class here is something that you yourself as a supplier has to implement. Okay? That's why they are effective. We'll see some example there. And now that's for the supplier side. Okay? Now for the client side, okay, you will see that over there I give you a container. Container there is actually iterable. So that's basically what we are declaring here. So this is the client. We say card should be iterable of order. Okay, that's one example there. So the client can actually now use the card or the container on your diagram to write a contract or to write implementation. And iPhone actually provides a very nice syntax called the cross syntax. Okay? I think it would be better for you to read over this across usages maybe later. I'm going to show you slides, some more examples to show you, to give you intuition. But you can see that the question mark and the exclamation mark in the diagram there, question mark means precondition. And so question mark in your block diagram, exclamation mark, so question mark is precondition. And exclamation mark is postcondition. Okay, and then you can see that I also have, yeah, that's, you can see, yeah, I also use the old expression there, okay? Let me draw your attention to one of the postconditions. Go to increase balance feature there. You can see the postcondition for that. You can see I say across old container dot deep twin. Okay, I'm actually going to go into detail, maybe not today, maybe next time, go into details why this is the only way, that's the only correct way to write the complete contract if you have some iterable collection attributes. Okay, so now let me go on to finish the iterated method. Okay, so that's the overall architecture here, and I'll put some lab exercise for you to actually do it. For example, you can now in your card class, you can now inherit the card from iterable. And in that case, you will be forced to define the new cursor feature. Okay? And then you have to somehow define the new cursor. Okay, I'll show you how you can do that. So this slide basically summarizes what you have to do for the supplier side. So basically I have supplier side and client side. Supplier side is about how you implement the iterable, and the client side is about how you use that. Okay, it's different. Okay, so supplier side, so actually I include all the details you have to follow. So when you do the exercise, just refer to these slides, and that should be quite, that should be enough. First of all, we have to know how the information hiding is applied for the supplier side. So we can see that changing the secrets internal workings of data structure should not affect any existing clients. Let's say from array to linked list, from linked list to tree, etc. So now we basically you want to instantiate the diagram here for your own purpose, right? So these two classes are already there. They are like the interface. So you're trying to make your own classes to be the descending classes of those interfaces. That's what you have to do. Okay, so we have to first to inherit the card from from the iterable. Okay, so for example, you'll be iterable of order, and then we have to define a new cursor, right? As I said before, because if you refer back to this diagram here, if you inherit from iterable, the defer feature there, the only one that's deferred there is new cursor. Okay, so now in the card class, we have to define a new cursor. And there are two possible ways of doing it. Okay, two possible ways of doing it, A or B. So if the internal structure that the card class is using is already a library type, for example, let's say for the first and second implementations here, so one is array, the other one is linked list. So those are already defined in IFO. And guess what? They are themselves iterable, which means they already have a new cursor feature defined, which means you can just use them from your code. So what you would do in the A solution here is simply just return the new cursor from the implementation. If the implementation is already some library type, that's iterable. Otherwise, let's say if this tree type here, this tree here, is actually something that you define by yourself. So that's not part of the IFO library. This case requires a little bit more labor. So we can, let me go back there. So we are talking about here. Let's say the tree you have here, so you actually have to have my tree iteration cursor to actually to implement how you do the in-order traversal of your tree in that class. So it will be my tree iteration cursor that will inherit from the iteration cursor class. Okay, it might sound a little bit abstract to you, but just do it, and you actually we'll actually do some exercise maybe tomorrow on this. Okay, so these are the two possible implementations here, and if you want to go for solution B, because you simply cannot reuse the existing implementation from the library type, then you actually have to implement the after item and fourth features yourself. Okay, just two possible solutions. Okay, it's more fun to actually look at how the clients can write a contract with each one. Okay, it's more fun. Okay, so now for the client side, the information hiding applies because now the clients do not at all have to depend on how the supplier implements the collection of data, array, linked list, or tree. I simply don't care. All I care is, how am I going to walk through all the elements in a linear way? Okay, as if I could just use a cursor. Right, so code to interface, not the implementation principle, because here I would say card is iterable of order rather than array or something. Okay, so now for iterable, and now we can actually use the syntax that's supported by IFO, and then write contracts about that. Okay, I'm going to show you a series of examples now. So sit tight. Okay, so now we talk about contracts first. Let's say we have a class called checker. Okay, it simply has a collection here which is iterable of integer, which means the client is only going to iterate through a collection of integers in a linear fashion. And let's say we have some feature here is all positive. So basically this is a Boolean query, which is going to check if the collection here contains positive integers only. Okay, that's what the feature is supposed to do. And that's simply the body here. I just ignore that because the focus now should be how you write the contracts. And now, this is the syntax that's supported by IFO. Okay, so you can see that, okay, the overall the syntax is not too bad. Let me erase this. Apparently, you can see that the advantage of this is you can see now the clients, if, let's say, if the supplier changes from linked list to array, or from array to tree, this part wouldn't change, would it? You wouldn't, because it's not affected at all. That's really why the pattern is so good for realizing the information hiding. So now for the cross syntax, we have to pay attention to that. So the syntax for a cross, let's just worry about the syntax for now. Cross. So this is a placeholder here. Cross S. Another place here, placeholder here. And then, so here we can have different keywords. Let's say, let me just use one of them. Okay? So sum is actually one of the possible keywords, or sum can be also or. Either way. Okay? And this or here corresponds to the universal quantification. And the sum here corresponds to the existential quantification. Okay? That's just something to note. And here, it has to be some Boolean expression. Okay? So here, so this here should be a let me say expression of I iterable okay, and this here is a the name and a cursor variable. Let me remind you about the architecture diagram. If you refer back to your diagram here and you look at there, so here you can see that iterable is supposed to return some new cursor. Okay? So basically you can see, you can think of the variable you have here is going to capture that new cursor. Okay? Okay, let's see how we use it. So now we're trying to say now go across the whole collection and let's say the cursor that's returned by this iterable here is simply called cursor. Okay? And what's the type of this cursor? This is very important. It's iteration cursor, actually. Okay? Okay, so here you can see that basically we're going to call, you can under the hood, IFO is going to call the collection dot new cursor, which is defined by the architecture here, new cursor here, and then it's going to assign that new cursor to this cursor here. Okay, so we can actually use this cursor here in the to define a Boolean expression. And here it's simply as simple as cursor.item larger than 0. And because this is actually cursor is an iteration cursor type, so you can see that one of the features that's defined is called item. That's the current item being iterated through. Okay? But that's a little bit too IFO. What does that really mean here? Well, what am I trying to say? It's actually very informative, but by just reading that. What does that mean? Not empty? Not quite. So because you're trying to compare the values, right? Because you're trying to say across the collection, overall, each item that I'm actually iterating through is actually greater than 0. Okay? And this actually corresponds to some mathematical expression, which you have to know. Okay, let me erase this, and then is it existential or universal? I hope we can get that right. Good, good. That's important. There exists some item there. such that item is a member of, as a set membership, remember, right? Is a member of collection and it is the case item larger than 0. So that's exactly this mathematical expression. Remember in the existential quantifier and the universal quantifier, you always have to say what's the type of the dummy variable, right? And then what's the range of that dummy variable, and then what's the predicate you're trying to assert. We're trying to say there exists some member in the collection, which is a type integer, that such that the item value is greater than 0, right? So if you have the collection like, 1, 2, 3, 4, right? So this will actually pass because you have at least one element there that's greater than 0. And if you have 1, minus 3, minus 4, minus 5, okay? Oh, actually, that's universal there, okay? So here, that should be for all, actually. Now it would be the same, basically. So the meaning would be different. If you actually change this from all to some, SOME, that's one of the keywords there, that means you only require one of the items to be positive. But if you change that from some to all, that means all of them should be positive. Okay, so it indeed corresponds to the universal and existential quantifier. Let's see another example. Okay? Another one, okay, so here, so let's say we have our bank class, and we have a list of accounts, and let's say we're trying to do a binary search in the accounts with a certain account ID, okay? Let's say somehow the key of the tree is actually the account ID, okay, which is unique. And now, because the precondition for doing a binary search is the collection must be sorted already, right? So now, so here, the list, which is itself also iterable, so this is okay. But now, see what I'm doing here. So here I'm saying, now across, so this is actually an expression here, and this expression creates an interval of integer from 1 up to this value minus 1. So let me give one example. So remember I said here, this should be an expression of type iterable. It does not have to be a variable. It can be something else. Do I have any 3 minutes or 2 minutes? What this is trying to say is, so we're trying to create, actually, let me see, this requires actually some explanation that I'm not going to tell. Okay, anyway, so I'll stop here, but give me 1 minute, okay? I'm going to tell you what I'm going to talk about next time. So next time, I'm going to give you simply more examples here, but I tell you what, I think so far I've covered just enough for you to understand the rest of the construct. So until we get to another pattern. So please, before next time, try to read through the slide.